Welcome back. So we're diving into ag again today, and specifically how to make it work in real-world scenarios.
Mm-hmm.
And one question that just keeps coming up over and over again is scalability.
Right. Right. Can this thing scale?
Exactly.
Yeah.
Like everyone wants to build these amazing applications, but what happens when you try to, you know, let it loose on a truly massive data set?
It's a big one. I mean, you can have the coolest ag application, but if it chokes when you hit it with real-world data,
Totally.
it's kind of a non-starter.
No one wants to be limited to a tiny little pool of data.
Exactly.
So we're talking about the big players, right? LangChain, Lamina Index, Pinecone, they're all trying to figure this out.
Yep.
But then you sent over some fascinating research from EyeLevel.ai.
Yeah, they're doing some really interesting stuff.
Yeah, and it seems like they're challenging some pretty fundamental assumptions about scaling RAG.
They are. I mean, the go-to solution for large amounts of data has always been vector databases.
Okay, so for anyone who hasn't gone, like, full tech nerd on this yet,
Right.
what exactly are vector databases?
So imagine like a massive library. But
Okay.
instead of books, you've got these chunks of information all represented as vectors.
Okay.
And these vectors, they're basically like maps, right? They capture the meaning and the relationships between different pieces of information.
Gotcha.
And that's super important for RAG because, you need to be able to find the most relevant info.
Right, right. You're searching for meaning, not just, like, keywords.
Exactly.
So is iLevel saying that these vector databases just don't work?
Not exactly. What they did is they put them to the test.
Okay.
It's specifically with RAG, right? They wanted to see how well they perform as the data set grows.
Okay.
And what they found was kind of surprising, even with like a relatively small data set,
Yeah.
talking like 10,000 pages.
Oh, wow. So even at 10,000 pages, we're already seeing issues.
Yeah, they started to see the accuracy of these vector databases drop off.
See, and that's way smaller than I would guessed.
Right.
I mean, most real-world data sets are going to completely dwarf that.
Absolutely. And it gets worse. By the time you hit 100,000 pages,
Oh, boy.
their research showed a significant dip in accuracy, like 10, 12%.
10 to 12%.
Yeah,
That might not sound like a lot, but when you think about it,
right.
if you're relying on a system to find critical information.
And that accuracy is going down as your knowledge base grows.
Yeah.
That's a problem.
That's a huge risk,
Mm-hmm.
especially with the sheer volume of information out there. So this isn't just theoretical.
No,
This has real-world implications.
it does.
So how do they explain this accuracy drop?
Well, their research suggests it all comes down to how the information is organized within that vector database.
Okay.
So even if the database is big enough to store all the data, if it's not organized in a way that like preserves the meaning,
Right.
the relationships between those data points,
Makes sense.
you're going to run into trouble.
So it's not just about having enough space. It's about, like, organizing that space in a way that makes sense.
Right. It's like you can have all the books in the world, but if your library's a mess,
Exactly.
you're never going to find anything.
You'll be wandering around forever. Okay, so this is where iLevel's own solution comes in, right?
Yeah.
GroundX.
GroundX, they've taken a totally different approach.
Okay, so spill the beans. What's the secret sauce? How are they handling this without vector databases?
Well, they got rid of the vectors.
They what?
Yeah, ditched them entirely. Instead of using vectors to represent meaning, they compare the similarity of what they call semantic objects.
Semantic objects. Okay, so what's it, like clusters of ideas?
Yeah, think of it like that. Instead of just isolated words or vectors, you've got these groups of related concepts.
Interesting. So it's more about understanding the connections, the context.
Exactly. And according to their research, it's working pretty well. At that same 100,000 page mark, they only saw a 2% accuracy loss.
2%. Compared to, was it 10 to 12?
Yeah.
That's a massive difference.
Yeah.
Especially when we're talking about, applications where accuracy is critical. Okay, but let's shift gears for a sec. This is all theoretical, right?
Sure.
You sent over this Reddit post, and it really got me thinking.
Oh, yeah, that's a good one.
A team tried to actually use LangChain in a real-world application.
Right.
And they ran into some serious roadblocks.
Yeah, it's a classic example of like theory versus practice.
Right.
They had this workflow, pretty standard stuff, parsing PDFs into text using LangChain and unstructured.io,
Okay.
and then feeding that into their RAG system.
Sounds pretty straightforward.
Right. You'd think so. but they hit a wall with parsing speed. It was a huge bottleneck.
Really? Even with, like, I mean, were they using GPUs?
Oh, yeah, they brought in the big guns. Still slow.
Hold on. GPUs, and it was still slow. How much data were they working with?
It wasn't even a massive data set. And here's the kicker. This wasn't some small team with limited resources. This was the EyeLevel.ai team.
Wait a minute. The same team behind all this groundbreaking research.
The same!
They were struggling with the very problem their research was trying to solve.
Yep. It just goes to show, scaling RAG is hard. Even for the experts. They actually had to reverse engineer parts of unstructured.io.
Reverse engineer it.
Yeah, to figure out how to get those GPUs working properly.
Going the extra mile.
Yeah.
But even after all that, did they make it work?
Eventually. But even with all their optimizations, they said parsing 100,000 pages took about 8 hours.
8 hours.
Yeah.
So even for the team pushing the boundaries, scaling is still a major hurdle. It makes you wonder, if these guys are hitting these roadblocks, what does that mean for, everyone else?
It's a good question. It's like we're at this crossroads, right?
Yeah.
You've got vector databases, the industry standard, but we're seeing these scaling issues, and then there's EyeLevel, kind of shaking things up with Ground X.
Yeah, it's like the classic tech story. The big guy versus the little guy.
Yeah.
The disruptor.
Totally.
Yeah.
And for someone like you, it creates a real decision point.
For sure.
Do you stick with the tried and true?
Yeah.
Even if you might have to deal with those scaling issues down the line? Or do you take a chance on something new?
Yeah, especially if it's, easier to use.
Hmm.
I imagine for a lot of developers, the simplicity of Ground X,
Oh, yeah.
being able to just upload your documents and start searching,
Huge.
that's got to be tempting.
It's a game changer, especially for smaller teams.
Yeah. So where does this all leave us?
Yeah.
What's the takeaway for someone listening who's been, following along with all this RG stuff?
I think the biggest thing is this field is moving so fast.
Oh,
What seems like a sure thing today
right.
could be obsolete tomorrow.
That's true in tech in general, but
It's especially true with RAG, though, right? I mean, this has the potential to completely change how we interact with information.
yeah.
So, yeah, stay informed, keep experimenting, and don't be afraid to, question what you think you know.
Always good advice. So in your deep dive into R, don't just focus on the nitty-gritty technical details.
Yeah.
Think about the big picture. What's it all mean? What could this unlock?
Absolutely. And on that note, I think this research from EyeLevel, it really makes you think.
Yeah.
Whether or not you think their solution is the answer, it forces you to confront some pretty fundamental questions about knowledge.
Like how we organize it, how we access it. It's fascinating.
It is. And those are questions worth asking.
Keep asking them. This has been great. Really appreciate it.
Anytime. This stuff is so interesting.
For sure. And for everyone listening, thanks for joining us for another deep dive.